All right, for this experiment we're going to be running, I think it's called molar mass of acid X or titration of KHP. So just to mention really quick, KHP really isn't necessarily potassium, hydrogen, phosphorus. It's a standardizing weak acid that we use to standardize NaOH, and it's potassium hydrogen phthalate. And it has a molar mass of 204.23. We don't necessarily need to know a lot of information about it, just that it does have that molar mass, which we're going to utilize that shortly. And so what we're going to be doing in this lab is a titration. And titrations are really good tools that chemists use a lot to determine unknown information about a substance from known information. So we have two equations here, which are beyond your lab. And this is the standardizing equation, and this is the equation we'll be using to determine the unknown. So looking at this one here, is we can take a look at the reaction. So I have KHP, and again, here it is. I'm going to grab a certain mass of this stuff, and I'm going to place it into a beaker. Actually, not a beaker, an Erlenmeyer flask. This little guy. So the Erlenmeyer flask is a tool that chemists use because they swirl really well. I can put a substance in here and do this and not have to worry about, flying all over the room. As opposed to a beaker, you can put a stirrer in there and do that as well. This just happens to work pretty well for this particular purpose. So I've put about 0.2-ish grams. I'm just making that up. So if I say I put in here 0.2 grams of KHP, and I know the concentration, the molar mass of it, and I said it was 204.23 grams. With the mass and the molar mass, I know, of course, the moles. So I can use this to get me some information about the NaOH eventually when I get there. So let's go ahead and take a look at, again, another piece of equipment that we use in the lab. This is called a Buret. And a Buret is a really good instrument to use for measuring volumes in the chemistry laboratory. It starts off reading at 0 here at the top, and it goes to 50 milliliters at the bottom. And it's got all these little lines in between that measure in tenths of milliliters. And you have this little guy down here called a stopcock, and you can just let it fly wide open and put in a whole bunch of volume, or you can get it to where it's just giving a drip at a time. And it works really well as far as measuring volumes. So I have this set up right here, and we'll run through the titration to figure out how many milliliters of NaOH I would use in this particular amount of mass of KHP. Now in running this, something very important you have to make sure before you actually run it is to make sure you have an indicator in there that shows a color change. So initially, this is all nice and clear. But with the indicator, it changes color at the equivalence point. Now the equivalence point is where the moles of the substance, the weak acid, and the moles of the base are equal. So it changes, and when we hit that color, that's called an end point. So hopefully if we line this up, the end point, based on the indicator, is within the same range of the equivalence point of the mole-to-mole ratio. And we'll talk more about that chemistry in just a few moments. Okay, so I have a few drops, just takes a few drops of the indicator in here. And again, when a color change happens, it'll be like a pinkish color. So I'll see if I can get this before it goes all the way over. You can kind of see that little bit of color, but if you swirl it, it goes away because, of course, there is still a lot of acid. Now, eventually, if I do this correctly, and I won't, the color change will be just the slightest bit of pink. If it goes to a really sharp, bright pink color, I've added more. I've gone past the equivalence point, and I'm now just in a basic solution, because if this solution is basic, it's bright pink. So I can kind of see again, it's like, oh, it's a little bit pink, but you swirl it, and it goes back. So I'm not going to spend the whole video doing this titration. I'm just getting it to a point where it's kind of close. So again, I think I overshot, and I definitely did. So that bright pink color, very bright pink, is too far. But this is okay. Many times you run titrations 2 or 3 times. So if I know the mass I used the last time I ran this lab, I can try to get as close to that mass again, take a look at my volume and say, okay, it took me 7 milliliters. I will go back and rerun it, same mass, and it should take something less than 7 milliliters. So I can shoot up to like, say, 6 or so, and then just go drop-wise, one drop at a time, until I get that nice, perfect, light pink color, and I'll say, okay, that's how much it should have taken. I'm at the equivalence point. In this case, I went past it, and that's perfectly okay. We can just make up this data. So with that information, and again, I'm going to go in and say, okay, it took me 6.5 milliliters, but I want it to be expressed in liters. So I will write 0.065 liters of NaOH. Now, if we recall what we were talking about earlier, let me move this out of the way. Earlier we said, okay, if I have this information, I can turn that into moles. So if I have the moles and I have the volume, I can now get the molarity of that solution. Now I'm just completely making this up, so the math isn't going to work. Let's pretend the molarity of the NaOH is 0.105. And this is really good information because now my base is standardized. So if it's standardized, I can use this for a variety of other experiments and have this as a new known. So I'm going to take that value and drop it down to this next equation, which is me figuring out the molar mass of an unknown acid. Now, as far as this goes, I'm telling you ahead of time that it's triprotic. And all that means is this unknown weak acid has 3 hydrogens to give, triprotic. Notice the mole ratio, it's a 3-to-1 ratio. So it takes 3 OHs to remove the 3 hydrogens. That's just the mole-to-mole ratio. Okay, so I rerun this lab, but of course I do measure this out, and let's just say I'm told to measure out 0.25 grams of this mystery acid. So I know this information, the 0.25 grams. I just weighed it on the balance. I'm running this lab, and this time when I'm doing the titration, using the same Buret, and I've known the beginning and I know the end, I know the volume. And the volume is 0.017 liters. So if I know the volume in liters, and I know the molarity, moles per liter, I can put those two values, multiply it out, and get the moles. If I know the moles of the NaOH, I can do a mole-to-mole ratio and figure out the moles of the unknown acid. If I know the moles of the unknown acid, and I know the mass of the unknown acid, that gives me the molar mass of the unknown acid. There we have it.